Okay, we're looking at homework 8.6 and we are looking at confidence intervals. And to see the steps in doing a confidence interval, first of all, you have to figure out the standard error of the mean, which is standard deviation divided by the square root of n, and the finite population correction factor, which is the population sample size minus the population size minus the sample size, and then the population minus 1. And once you get those two numbers and your critical z-value, you do your z-value times your standard area of your mean times your finite population correction factor. 3 numbers here. And then you do your mean plus the product of these 3 numbers and your mean minus the product of these 3 numbers. So there's 3 important numbers that you have to calculate or look up. So for this question, first of all, we need to find the 90% confidence interval. Well, the first thing we want to do is do the standard error of the mean, which is the standard deviation divided by the square root of n. And we know that the standard deviation is 20 and the square root of n is 30, and you end up getting 3.6515. And then your population correction factor is big N minus little n. Well, we know big N is 300, little n is 30, and then big N again minus 1, and you get 0.9503. So we have 1 number and 2 numbers. Remember, we have to do 3. We have to get 1 more number. We need to figure out a 90% confidence interval. So what you need to do is you need to go back to your table that we've gone over before in the videos. If you go into Canvas and you go into your modules, you can look it up in the module that says Proctored Exams Formula Sheet. And if you'll just, the best thing I would do when I'm working this homework is either copy this table down or print it off, because it will save you a lot of time. Or you can just do like I do and keep this tab open. Usually I have it directly open to that, but I was looking at my textbook. Remember, always look at your bookshelf and go over the chapter so you can kind of understand what you're doing as you're going through these sections. That always helps. But this table you'll use a lot. Another suggestion, maybe take a picture of it with your phone or your iPad. It's thinking. Here it comes. So if we scroll down to the bottom, we can see that our Z critical value for 90% confidence interval is 1.645. So if we look back at our values here, remember we had already figured out some of our values. Now we know the mean is 70 plus, we're going to do 70 plus and 70 minus the Z value 1.645, and then the two values we calculated 3.6515 and 0.9503. It's important that you round 4 decimal places on these two numbers in order to get the exact number. So if you do 70 minus that, you end up getting, when you round to 2 decimal places, 64.29. And then if you do 70 plus the product of these 3 numbers, you end up getting 75.71 when you round to 2 decimal places. Okay, moving on to the next problem, question number 2. You can see that We want a 99% confidence interval, and if you look at the 99% confidence interval, if you look at your table, the z-value is 2.575, I believe. Wait, let me make sure I'm on the right question. 99% confidence interval. We're going to skip number 2 because obviously I didn't work it, but it's just, if you work it the same way. Number 3, a 95% confidence interval. If you look on the table here, 95% is 1.96, so we're going to use 1.96 when we're working this for our z-value. So we know we're going to do the mean, which is 23. We're going to do, okay, this is a proportion one, so you have to, because we don't know the standard deviation, so what you have to do is get the proportion, which is x divided by n. 23 out of 75, and 23 out of 75 would be 0.3067. So everything is a proportion in this one. Now, to find the standard error of the proportion, you do the square root of the proportion, which is 0.3067, times 1 minus the proportion, and that would be 0.6933, divided by n, which is 75. So when you do that and you round to 4 decimal places, you get 0.0532. So the standard error of the proportion is 0.0532. So now we have to find the correction factor, which is n minus n, big N minus little n. So big N is 500 minus little n, which is 75 over 500 minus 1. And when you do all of that, I believe you get 0.9229. So here's your 3 numbers you have to multiply together. So you're going to do the proportion 0.3067 plus or minus 1.96 times 0.0532 times 0.9229. So once you do that, when you do 0.3067 minus all of that, you get 0.210. And when you do 0.3067 plus those 3 numbers, you get 0.403. Be careful on this one. Everything has to be a proportion here because you don't have the standard deviation. Okay, for this one, your proportion is 190 out of 500. Okay, and when you do 190 out of 500, you get 0.38. And then, so you would do your standard error of your proportion, which would be 0.38. 1 minus 0.38 would be 0.62 over n, which is 500. So you end up getting 0.0217. And then your population correction factor is 3,600 minus 500 over 3,600 minus 1. You're just plugging in the formula and you will get 0.9281. Okay, so when you do all of that, you end up getting 0.38 plus or minus 0.0217 times 0.9281 times 1.96. You're going to do plus and minus that. So 0.38 plus this times this times this, and then 0.38 minus this times this times this. Use a TI-83 or 84 calculator so you can put it all in there at one time. Okay, moving on. Okay, on this one we're doing a 99% confidence interval. So what we will have to do is use the t distribution here. Okay, on this one we will use the t-table because n is 22. So we are looking for a 99% confidence interval with degrees of freedom of 22 minus 1, which is 21. So if you go to your textbook, to your appendix in your textbook, you can look that up. So I've already got it pulled up. Here's 90% confidence interval 2.831 is what we're going to use here. So let's do 2.831 as our critical value. So for our standard error of our mean, we know that it is the standard deviation divided by the square root of n, which is 22. And when we put that in, we get 0.2985. And then for the second part, the population correction factor, we do 300 minus 22 over 300 minus 1. Big N minus little n over n minus 1. And if you look at the example, you can always get the formula from the example. It will provide the formula. So 0.9642. So we're going to do 7.6 plus and minus our critical value, t value, 2.831 times 0.2985 times 0.9642. And once you do all of that, this is the confidence interval you will get here, 6.79, 8.41. What assumptions need to be made for this analysis? When we're doing this t analysis using the t value, we need to assume the population is normally distributed. If you get confused on anything, remember to round to 4 decimal places on your two numbers here, and also to always look at the example and work the example first. Try to go through it and then go back and work your homework.